Hey everyone, and welcome. This explainer comes to you from our friends at Forge College. So if you just came from our lesson on lifetimes, you know all about Rust's borrow checker. And you've probably spent some quality time fighting with it. Well, that struggle, it's usually a sign that we need a better plan from the get-go. Today, we're going to learn how to use Rust's module system to build big, powerful Solana programs that actually work with the borrow checker, not against it. Let's dive in.
So here's our menu for today. We'll start with a recipe for disaster. What happens when a project is total chaos? Then we'll see how to organize our coding kitchen, meet our expert crew of modules, and write the recipes or functions they'll all follow. We'll wrap it all up in a master cookbook, and then, well, it'll be your turn to cook.
All right, first up, let's really set the scene. You know, every great chef knows that chaos is the #1 enemy of a great meal. And guess what? It's exactly the same for coding.
Have you ever been there? Deep in a project where everything's just everywhere? Functions are all over the place, nobody knows who owns what data, and you're spending way more time wrestling with the compiler than actually writing cool logic. That's the chaotic kitchen. It's that moment of pure frustration when one tiny change triggers a whole cascade of those lifetime errors we just learned about, and you end up just cloning data left and right to make it shut up. We've all been there. It is the #1 sign that we need a better plan before we write a single line of code.
So, how do we get out of this mess? We need a system. It's time to bring some of that Michelin-starred discipline into our project by, you guessed it, organizing our kitchen.
The solution is to stop thinking about our program as one giant, messy file and start thinking of it like a professional kitchen, right? In a world-class restaurant, you've got different stations, different chefs, each with a very specific job. The pastry chef isn't grilling steaks, and the sommelier isn't chopping onions. And in Rust, that's exactly what modules let us do. Each module becomes a specialist on our team with a super clear role. This is what stops the confusion, the rework, and everyone stepping on each other's toes.
For a typical Solana program, we can kick things off with a core crew of 3 expert modules. So, let's meet them.
First up is the accounts module. I want you to think of this as your program's micro D. When a new transaction comes in, this module is the first to greet it. It checks the reservation list, verifies the signers, and makes sure all the right accounts are at the right table. Its job isn't to do the heavy lifting or the logic, it's just to parse all that incoming info and validate access before anyone else gets involved.
Next, we've got our state module. This is our super meticulous pantry manager. This module is responsible for all the raw ingredients, all of your program's data. It handles serialization, which is just a fancy way of saying it turns your complex data into a stream of bytes so it can be stored on chain. And it handles deserialization, turning those bytes back into useful data your program can work with. It makes sure everything is perfectly prepped for the chef.
And finally, the star of the show, the processor module. This is our head chef. The processor takes that validated order from the accounts module and the perfectly prepped ingredients from the state module, and this is where the magic happens. It executes all the core business logic, orchestrates the changes in state, and creates the final dish.
Okay, so check this out. This is how we make that kitchen analogy real. You can see the accounts module is laser-focused on one thing: parse accounts. The state module, it just handles data conversion with from bytes and to bytes. And the processor pulls it all together with process instruction. The real takeaway here is that this clean kitchen idea isn't just a nice way to think about things. It translates directly into a clear, functional, and super organized code structure.
All right, our crew is assembled. Now it's time to give them crystal clear instructions. In our world, these recipes are the public interfaces and function signatures that define exactly how these modules are going to work together.
Let's look at the recipe for our accounts module. Now, the key ingredient here is the accounts A struct. See that little KIA? That's a lifetime parameter. And what it means is that this struct borrows the account information instead of trying to own it. So why is this such a big deal? Well, it tells the compiler and any other developer that this module's job is just to read and validate the data, not to keep it. This one little design choice prevents an entire class of ownership errors and, believe me, avoids so much costly, unnecessary data cloning. It's a precise, efficient recipe.
Now for the head chef's recipe. The process instruction function borrows that clean, validated accounts struct. See? It doesn't care about the messy details of parsing. It just gets a perfect order delivered to its station. Then it gets an own state object from the state module that it has full permission to change. This is the perfect flow of ownership. You borrow what you only need to read, and you own what you need to change. It's that simple. Okay, time to put it all together. For your Capstone project, you're not just going to think about this stuff. You're actually going to create a plan, your very own master cookbook.
And what you'll deliver is a simple, one-page integration plan. It's really just a three-step process. First, you list your files and the main function signatures for each module. Second, you write just a short little paragraph for each function defining what its job is. And third, you document your key lifetime choices, like explaining why you decided to borrow account info. This isn't boring paperwork. This is your blueprint. It's going to save you hours of debugging down the road.
And with that, we're ready to wrap this up and get you into the kitchen. Let's just quickly recap the guiding principles here. So here are the 3 things to remember. 1. Enforce clear ownership boundaries. Your accounts module is the maitre d', state is the pantry manager, and processor is the head chef. Keep them in their lanes. 2. Make your ownership intentions explicit right there in the function signatures. This turns the compiler from an enemy into your helpful assistant. And 3. Document all of this in a simple one-page plan. It is the single best tool you have to prevent messy code and keep your project on track.
So there you have it. You now have the blueprint for organizing a clean, efficient, professional-grade Rust program for Solana. You've gone from just fighting the borrow checker to actually using the ownership system to design better software. So the only question left is, what masterpiece are you going to cook up?
This explainer was brought to you by Forge College. If you want to dive deeper into Solana development, Rust, or any other Web3 topics, make sure to visit forge.college to learn more. Thanks so much for tuning in.